Hi everyone, and thank you for joining us today. My name is Tina. I am the Capability Building Coordinator for Connecting Up and TechSoup New Zealand. Connecting Up is a part of the Info Exchange Group. Info Exchange is a not-for-profit social enterprise that has delivered technology for social justice for over 25 years. With over 100 staff across Australia and New Zealand, we tackle the biggest social challenges through the smart and creative use of technology. I'd like to welcome you all to the webinar, What is AI and How Can It Help Your Nonprofit Organisation, which will be presented by James Hornitsky from Leafcutter. We'll start with a little bit of housekeeping. All lines are muted, so if you have any technical issues, please type it into the questions box on your webinar panel and I'll be able to assist you through there. If you have any questions during the session, please also type it into the questions box and James will answer them in the Q&A section at the end of the webinar. Please note that your comments and questions will not appear to the entire group. If you are on a Wi-Fi connection and have multiple programs open, this can sometimes affect the quality of the audio and video of the webinar. If possible, please close all other programs to help you have the best experience. Please note that the webinar is being recorded and a link to the recording and the slides will be sent to you shortly after the webinar ends. Before we start, I'd also like to remind you that there is a short survey at the end of the webinar. We'd appreciate it if you took a few minutes to provide us with some feedback. That's all from me for now. I'll pass it over to James to get things started. Thanks, James.
Thanks very much, Tina. Hi, everyone. First to introduce myself. My name is James Hornitsky. I'm the Chief Operating Officer of Leafcutter and one of its co-founders. We've been around for 8 years doing various website and web app sort of technology solutions for not-for-profits. I'm pretty excited today to get the chance to talk about AI because it's definitely one of my passions. And it's an emerging technology, as you probably already know, that's going to change the way things work over the next sort of decade. Just before we get started, we have a quick poll that we want to run to understand sort of who's in the room listening and maybe help sort of guide some of the content or some of the input that we give. So if you could just fill that out quickly, that would be really, really good. While we leave that poll up for the next 30 seconds or so, just want to give you guys a bit of an overview, I guess, of my background and how I got into AI. I've obviously been leading Leafcutter for the past 8 years, but prior to that, I'd worked previously at IBM and Westpac, and I also attended the University of Technology, Sydney, for my undergrad and honours degree. As part of that time at university, I did a little bit of AI work in RoboCup, and that was pretty exciting. I'll be able to show you guys a quick video of what I did, but basically it was making robots play soccer against each other, which is quite a challenging thing to do. Let me give you a little idea of what that looks like. So I'll just run this here. So this is actually a really challenging AI kind of problem. It involves a lot of different skills in terms of vision, detecting objects, detecting other players, detecting balls, strategy, coordinating 3 or 4 different robot players on the pitch together, and then obviously motion, so making sure you can kick a goal. And as you saw, that was actually, I think, the winning team from the year that I did the RoboCup competition. So I've got a sort of, I guess, a 10-year-old sort of quite detailed level of input on the sector. And the field has advanced a lot in the last 10 years, and it's sort of moved, I guess, a little bit out of research into a bit more of the practical kind of space, which is what we'll talk about today. But definitely that's sort of where I got my first look at it, and it was really exciting then. I think the fact that it's more accessible now and a bit more, I guess, practical is also quite good. So that's what I'd like to explore today. So there are 3 kind of points today that I'd like to cover off, and then we'll have Q&A at the end. The first is, what is AI? So there are a lot of definitions of AI out there. There are a lot of technologies that could be considered AI or not. I don't believe there's a hard line for these kind of things, but I want to at least give everyone a definition and understanding, especially if you're pretty new to the technology and sector. The second part will be sort of some common use cases or applications where I can see that NFPs can use AI, and a couple of different ways to think about when to use which sort of solution. And then the third area will be how to get started. So just some really basic tips for looking at which problems can be solved by AI, what sort of people you need, and how do you structure an AI project as well. As I mentioned, please add your questions and comments in the chat so that at the end we can have a bit of a Q&A there and talk a little around that. So without further ado, I think we'll jump straight into it, and let's have a look at what AI is. So for me, obviously AI stands for artificial intelligence. Another common term that's commonly used is machine learning. I use them pretty interchangeably. And my definition of AI is a broad set of mathematical techniques employed at scale that simulate or surpass aspects of human intelligence. And it's mainly around pattern matching. You'll see in the following slides, AI is not about creating human intelligence as a whole, or it's not there today. It's about taking specific aspects or specific problems that human intelligence is good at solving and learning how to apply that. So let me give you just a quick practical example of sort of what an AI script looks like behind the scenes. So if we go here, I've got this sort of notebook up. It's called Collaboratory, and this is an online sort of learning environment anyone can access that's provided by Google to run machine learning scripts. Now, I've already been through this script. It's quite a long script, but basically what it does is it takes two images. So in this case, we've got an image of a total, an image of a wave, quite a famous painting by a Japanese artist, and it combines the two into a new image, right? That's all this script does. So if I scroll all the way down through all the sort of script here, all the code here, and I get to the point where we actually see it working in practice, what we'll see here is basically this is what machine learning is. It's taking a large data set or a large corpus or whatever you call it, and it's basically repeating experiments over and over again, right, until you get to your outcome. So what you'll see here is basically this script that's running is taking the first image, which is total. It's taking the image of the wave. It's trying to mash them together, and sort of pixel by pixel, it's trying to work out the mathematical distance between the original image, the last image, and sort of minimize that as fast as possible, just to put it in the simplest terms I can. And what you'll see is what machines are really good at here. Machines can do things endlessly. They don't get tired. They can do it very quickly. And what you'll see is it running lots and lots of iterations as it started with something that was quite far apart, and it gets closer and closer and closer. And this is going to run 1,000 iterations. This is currently at 400 iterations for it to sort of develop the best model of mashing these two images together. And that's really, I think, a good illustration of what machine learning is. There's a bunch of mathematical code that I scrolled through earlier, and it basically repeats that over and over and over. It minimizes the loss function, or minimizes, sort of increases the accuracy as time goes on, and it produces an output. And this is, again, probably a practical way that you can see it in action, where it starts from something quite basic and it just keeps iterating to get to that final sort of model or state. So hopefully that gives you a bit of a practical example of what AI is in practice. If we go back to the presentation, let's talk about why AI is so popular right now. Obviously, there's been a lot of hype in the past, probably, I would say 3 years, in terms of why AI is popular. A lot of startups are raising funds off it. A lot of businesses are adopting the technology. It's very big in the news, and there's a lot of hype around it. What I've got here is the Gartner hype cycle graph, which displays a a number of different AI technologies and sort of where they sit in terms of adoption. What you'll see is that most are clustering around the top. And I think that's probably accurate because there's been a lot of investment and a lot of publicity over the last five or so years in this. I guess the question is really why. I think there's a couple of factors in it. The technology is a lot more accessible now. So there's a lot more over the past 10, 15 years that people have done with Amazon Web Services, with Azure, with cloud computing in general. And that's made the underlying infrastructure that you need a lot more available. It's a lot easier to get access to it. Probably the other big thing is that there have been, in the past 10 or so years, some pretty big advancements in the accuracy of machine learning, in particular image recognition. So in a number of fields now, AI will actually beat people in terms of recognizing images or labeling images, which previously wasn't possible. And a lot of that's due to a specific type of, I guess, algorithms or families of techniques called deep learning, which we'll cover in a little bit. But deep learning has really made it possible to get a much higher degree of accuracy than before. And that's basically allowed it to surpass humans, which is why there's a lot of interest. So I think really combining the infrastructure availability with the deep learning sort of breakthroughs that we've had over the past 10 years is why you're seeing a lot more in AI right now. And I think if you look at the top of that graph, I mean, I don't have absolute faith in these Gartner graphs, but if you look at the top of that graph and you see what comes next, which is the trough of disillusionment, I think that's going to happen to some extent. I think we are seeing sort of peak hype around AI, and there will be a bit of a drop-off, particularly in terms of startup funding. But I do think it is obviously having a pretty big impact today, and it will sort of recover and keep going over the next 5 to 10 years. So it's definitely something to be very, very aware of, and it's something I think that if you're looking at now, you're in the right sort of time and space to be doing that. Probably one more thing that's interesting about this is while the techniques are different now, there was probably a similar cycle of hype probably in the 1980s. And a lot of that came from new techniques, like neural nets were invented then, and a lot of AI progress was made in the 80s, and it probably entered a similar cycle. There were people predicting in the 80s that by the 2000s we would have Terminators everywhere. Obviously that hasn't happened, but this hype cycle has happened before, but this time it's a little bit different. We have a lot more there now than we did before. There's a lot more access to it. I think it's going to be more like, while we'll have the trough, will be more of a gradual kind of increase over time. So that's why I think that AI is popular now. How it works, so as you would have saw from the the really quick example I showed you before, basically it's the machine repeating something over and over again until it gets the loss function down, which you see up the top right, and the accuracy down the bottom right increases to a satisfactory level, right? That's the great thing about machines. They don't tire, they can keep working. It's basically repeating the same mathematical calculations over and over again until you get to what's called a model or a place that works and the predictions are accurate. The analogy that I like to use is Thomas Edison. I've not failed, I've just found 10,000 ways that won't work. That's what he said when he invented the light bulb. So you can think of it as like I guess, electric Thomas Edison. And the other thing that's really, really important about AI is that it's very much about probability. So traditional programming or anything in general, you sort of say, I want this to happen, now I want that to happen, then that happens, and that results in that. It's very much step-based, and there's a defined set of outcomes generally. With AI, it's pretty much all probability. So if you can see on this picture, this is it's probably taken from any AI tool, but as you can see from this picture, there's sort of boxes around different objects, and there's a number next to those boxes, which is the confidence that the AI has actually identified the right thing. So if you look at the bus there, the bus has 98.09 next to it. That's really the AI saying, hey, I see a bus here, and I'm 98% confident that this is a bus, right? There's a person in front of him, which is probably not the best place to be in that traffic, but there's a person in front of him. I'm 77% confident as the AI that that's a person, and I'm 80% confident that that's a bicycle, right? So thinking about AI this way is a little bit different. Again, with traditional programming and most things, you go step 1, step 2, step 3 equals step 4. AI is a little bit different in that it goes, I've done all these steps and I'm pretty sure it's this, or I'm not quite sure it's this, right? And this becomes really important to look at later. There's an element of risk, which we'll talk about when it comes to AI projects. Now, there's a lot of different machine learning sort of algorithms and techniques. I'm not going to go through them all now, but basically there's probably 3 sort of main categories, or really 2 main categories. Supervised learning, which is where you give your AI a data set, which is sort of pre-labeled or pre-vetted by yourself. Unsupervised, where you don't know what's in the data set exactly and you ask the machine to find patterns by itself. And then reinforcement, which is sort of a blend, I guess, of a few different techniques. But really there's sort of 2 main kind of families. There's a lot of different, I guess, types of algorithms. I'm not going to go through them all now. Probably the one that you've heard the most about and the one that's getting the most traction right now is neural nets, because they lead to deep learning, which is the next slide. So a neural network is a sort of, I guess, tries to simulate the way that the brain works, and that there's different layers of what you call neurons, or inputs and outputs. Whereas before in the 1980s, we used to have maybe 1 or 2 layers. With deep learning, we have lots and lots of layers. And the reason that works so well, people don't entirely know, because neural networks write themselves to a certain extent. But basically, they're better at cutting apart different features. And sort of as each layer goes on, there's more and more detail that gets pulled out at each layer. So that at the end result, you have quite that sort of breakdown layer by layer results in a more accurate prediction, I guess is the best way to put it. And this deep learning is only really possible with a lot more computing infrastructure that we have today. Again, like I said, Google Cloud Platform, Amazon Web Services, IBM Watson, they weren't there 10, 20 years ago. They are there here today, and they're the reason we can do a lot of stuff with deep learning, right? So I guess I've gone through a lot of technical bits. Just to sum it up, what today's AI can do, it can recognize voice and text. Obviously, if you use Siri, it's a good example of that every day. They can classify images. They can even read video streams. Very good at doing that. Approaching for a lot of applications the point where they can surpass or match or surpass humans. They can recommend movies, choices, etc. So obviously, if you've watched Netflix or if you've looked at Tinder, they all have different versions of AI in there, varying levels, and it can help make smart recommendations. And they can also simulate various scenarios and outcomes. So similar to that RoboCup example I showed you, you can use AI to develop sort of strategies for specific games or scenarios. I think that's the best representation of that, is that the pinnacle of AI achievement, I think probably from my perspective today, was when Deep Blue beat Kasparov. So Kasparov was probably one of the best chess grandmasters of all time. And he was beaten by Deep Blue, I think it was about 10, 15 years ago. And that was the first time that a computer had ever beat a human, like a really well-respected human, in a game of anything, really. And that's really, I guess, shows what computers are really good at with AI. They're good at solving a narrow problem, because chess, while it's a complex game in terms of outcomes, it still has very tight rules. They're very good at solving a narrow problem and beating people at that. Now, there are a lot of things that they can't do. If I just show you a quick video of this. This is the DARPA Robotics Challenge, which is where they basically challenge different robotics teams to develop robots that are able to complete a number of challenges that you might have in a rescue type situation. So moving over uneven terrain, opening doors, navigating through buildings or picking stuff up. And as you can see, something as simple as walking, as opening a door, AI seems to struggle with that. And this is probably about 3 years old, so things have come a bit further, but the message is still the same. AI is it's, oh, if I just go to the next slide, AI is less Terminator, it's less general purpose, and it's more like this example of the cucumber sorter. It's more very narrow or very domain specific, and it gives you the ability, though, if you get it right, to solve those problems at scale, right? So that's really the way to think about AI. We're not in danger of losing all our jobs tomorrow. We're not going to have Terminators come over and take over the world. But what you are going to see with today's AI and over the next 5-10 years is that specific roles or specific functions are going to be automated or augmented by AI systems that are really good at doing one, maybe two things. Okay, so if we move on from that, then let's talk about sort of the main crux of today. How can you take all that information I've just run through about what AI is and point them at solving non-profit challenges? And there's not an easy answer to this. Really, I think a lot of businesses in general are finding it challenging to understand what AI is and then how they can apply it to solving their challenges. So I don't think there's anything overly unique about the non-profit challenge, but there are a couple of nuances that's worth going through. I think the first thing to do is to classify the challenges into sort of two baskets. So the first is sort of common challenges, like most industries, there are some common problems that are common across non-profits, even across businesses as well. And there are sort of, I guess, off-the-shelf solutions, you could say, for them. And then there are your unique challenges. So, excuse me, items unique to yourself, which, you know, maybe you have a very specific type of research that you guys do at your NFP. That's something that no one else does. That's a unique challenge that no one else can sort of solve. You have to solve that yourself, and that's where you obviously have to apply a lot more time and investment to sort of get the solution to that. But there's sort of two baskets that I put them into. So with common challenges, I've got a few examples here today: automating customer service or supporter service, image and video recognition, so automating maybe some manual work that some of your volunteers do or some of your staff do, transcribing audio/video, same thing. Fundraising campaigns, a couple of quick examples there, and then generally improving your operations, which would be the same for any, I guess, organization, non-profit or for-profit, but some items there. And then on the unique challenges, creating a unique supporter experience, so an example there, research, obviously if you're research driven, there's plenty of opportunities there. And improving service delivery, so some unique ideas, I guess, you could apply to yourself. So if we look at the first one, automating customer service, if we look on the left here, this is just a quick video, which is probably the sort of, I guess, stock standard use case, which is a booking app. And this is using a platform called Chatbot Kusu. There are so many chatbot platforms out there right now. But what using something like a chatbot allows you to do is basically takes a little bit of that sort of workload, I guess, off some of your employees or staff or volunteers, and allows you to, I guess, codify that and create a sort of assistant that's available on multiple channels. You know, it doesn't get tired, follows the script most times, every time really. And basically allows you to increase the reach and effectiveness of your organization. Now, there are like I mentioned, there are quite a few good tools out there. One of them, I've got an example in here, is the Dialogflow sort of framework from Google. And basically the way that most chatbots work is they're based around intents. So an intent is basically an action that someone wants to take. So for instance, if you were an animal-based charity, an intent might be, I want to adopt, right? And based on that intent, there'd be a whole sort of, I guess, flow in here, or a whole set of phrases or different entry points that you'll draw up, probably similar to how you would plan your sort of call center script. And these are represented in tools like Dialogflow as a sort of, I guess, tree. And then what happens is that there's sort of machine learning algorithms which basically map the closest intent to the user's input and the words that they provide, right? Now, you can take these chatbots also a lot further if you've got the technical skill. You can apply custom training. You can integrate them with backend services, which is quite common. So in that booking example that we had there on the left, you know, our state of reservation, time of reservation, it will look up how many rooms are available in the hotel system. So there's normally an element of integration there, and that's a bit of technical work. But at least getting started with the idea of a chatbot, creating a set of intents, which is like a script, I guess, for the chatbot to follow, and then letting the sort of machine learning map the user input to those intents. That's how these sort of tools work, and that's definitely a reasonably common use case that I think most NFPs could get a lot of benefit out of. The next use case that I've got here is image and video recognition. So obviously the example that I gave before, machines are really good at, are now quite good at working out what things are. And if you had a massive data set, let's say again, if you're an animal or a wildlife charity, and you wanted to identify from a series of, I guess, field shots, which shots had animals in them and which didn't. This is the sort of thing that you can automate and use machine learning or AI to do this sort of work. There's an example here that I've got in terms of using a tool called AWS Recognition. If I jump forward a little bit, basically it's an online tool which is part of the AWS platform, relatively easy to use. You can upload your images to it, and it will basically work out what's in the image for you. And you can do that without much coding. Obviously, if you want to use this in a production application, you have to write some sort of integration or API connection to it. But basically, this is sort of ready out of the box image recognition, and there's also a video recognition version as well that you can use today without too much trouble. So like I said, there's probably going to be some pretty unique use cases around this. It's maybe not applicable for anyone, but again, if you have a specific use case, if you're looking at a task where you need to process a large number of images, then definitely that's something that you can automate and do with AI. The next one, transcribing audio and video. Again, this is a similar thing. The algorithms that Google has and AWS have are quite good to a certain standard in terms of recognizing audio and video from a given input. So either an audio file like an MP4 or a WAV file, or even a video file. And obviously, if you're in a position where you need to record, you need to take transcripts of audio that you may need to analyze later. So let's say you're a medical charity, you may do planning meetings, or a disability charity, you may do planning meetings with your clients for the NDIS, and you potentially want to take recordings of those and later transcribe them so you can run some sort of analysis on them later. That technology to do that is there today, and that will, instead of, I guess, getting staff to type up notes or someone else to transcribe those recordings, you could run it through AWS, for instance, and basically automate probably 80% of that work. So again, this is just I guess a flip on the image recognition example. Again, probably quite case specific, but if you have a case there to use it, it's very accessible and quite easy to do. Fundraising campaigns. So obviously with fundraising campaigns, there's probably already a bit of AI built into that with sort of marketing automation, working out what time of day to send things, A/B split testing, that's already built into a lot of the tools. I suppose the next level that I've seen used in a couple of cases is sort of chatbots that are designed around specific fundraising campaigns. That's one of the examples that I've got up on screen, where basically this is a Facebook bot, looks like that a charity's built. And it basically has a conversation with the user about, what the campaign's about, sends a little bit of content and sort of drives people to take action or to donate. I think this is an easy evolution or easy step beyond sort of the standard marketing automation email campaigns. It's not that different in terms of the thinking, and that you're planning a journey, but I guess that journey is a little bit more interactive and it's a little bit more open-ended. And what's important about this is that it complements the other aspects of a fundraising campaign. It's not going to replace marketing automation. It's not going to replace the other email marketing or whatever Facebook marketing that you already do. This is just another thing that you can add on, and it's probably really helpful in developing a more open-ended journey. The last one that we've got in terms of the common challenges is improving sort of operations. So your CRM, your finance systems, there's probably a bunch of other systems, ERPs or whatever you may have. And there's opportunities to build AI in there. Now, I'm not going to run through this example, but this example, if for anyone who's got Salesforce, there's a little app called Einstein that they've built, and that allows you to sort of automate some common actions like creating tasks or calendar invites based on certain actions, or to do intelligent lead scoring. So those are the sort of ways that I think, again, these sort of features are being built into the platforms that you have, but there's ways, I think, to sort of maybe extend them a little bit further or push them a little bit further. And definitely in at least the Salesforce example, that's available to you. So anyone who has Salesforce, I recommend they have a quick watch of that afterward and get a few ideas off that about how they can automate or improve a couple of things. So moving on from the common challenges, there are obviously things that are unique about you. Another thing that's unique about you, your organization, is going to take a bit more work to get right. Now, there's a really interesting talk, and again, it's a bit long, but I would recommend you watch, by this man. He's really good about talking about sort of personalized or predictive philanthropy, and being really targeted in terms of the way that we engage with our supporters. So rather than, I guess, relying on the traditional segmentation that we might rely on, he's talking more about a future where machine learning drives the messages and the interactions that we do with supporters. A good watch, probably a bit too futuristic, but what I wanted to do is, if I just play this on the left, this is an example, of course, by Charity Water, and they designed a Facebook Messenger bot that simulates a sort of person or a beneficiary of theirs, and basically I think it's an hour or 2 hours or so that this chatbot is able to interact with the potential donor or donor, and basically walks them through the journey of what this person does every day. It shows them a map, it shows them video, it shows them different experiences. And the idea is obviously to create that more, which is strange, but the idea is to create more of that personal interaction, but obviously to do it at scale, which AI can do and can automate as well. So that's pretty interesting if you actually spend the time to watch that video through. As you can see, it's quite a it's quite a conversational flow, and it's a lot more interactive than what you'd be able to do previously without AI. So if we go to the next one, if you're a research-based organization, and again, this doesn't apply to everyone, research is a massive field, particularly medical research, are having huge breakthroughs in terms of using AI. In some cases, there are some papers and some instances where people are claiming the AI is as good or better than human practitioners. But whichever way you look at it, AI is able to sort of, I guess, analyze the massive data set that we have available today and be able to sort of surface some of the most interesting patterns that allow us to detect things earlier. And this talk here, which is really good, if you're in the medical research space, you definitely want to be watching this. This sort of talk here sort of walks through a lot of the cutting edge research that he's doing in the US, and sort of shows the different, gives you an idea of sort of different patterns that the AI is looking at. Again, probably not that different to the image sort of analysis that we were talking about earlier, the image and video recognition, but a lot more specialized and obviously a lot more highly trained, I guess, than the generic sort of Amazon recognition stuff. But research, definitely, if you're in the research sector, AI is very big. There's plenty of grants and that out there, plenty of startups out there as well. A lot of good opportunities to partner and look for ways to deliver the mission better, I think. And then the last one that I've got here is improving service delivery. So this is a very open-ended kind of topic, I guess. The example that I've got here is the New York Blood Center, who I think 2 years ago were partnering with an AI firm to work out how many, well, obviously how many of the donors they had, which ones were more likely to donate, and how to keep them donating. So really similar, I guess, to the fundraising problem of what's the retention rate of regular givers, how do I retain more? These guys in New York were doing that for blood donors. I don't know of how much success they actually ended up having, but definitely that kind of, I guess, problem where you have something, where you have a problem where you think, look, if I had an additional bit of insight, or if I knew this or that about them, and you have the data already, we could maybe do a lot better. I think there are probably a lot of opportunities there for specific service delivery improvement that can be done through AI. And I think it's really up to you to sort of find those. They're quite unique, but I think there's a lot of potential in those if you do manage to find them. So those were a few examples, I suppose, of how you might be able to apply AI to not-for-profits. Some of them are quite common, like I said, they're common problems that most nonprofits and most for-profits in general have. And then there are some unique challenges, I guess, that you might only have some big problems, but if you can sort of automate them or solve them, you can probably get a really big win and really big outcome. So the last part of the presentation, how to get started. This is sort of taking all that. So we've gone through what AI is, we've gone through some of those applications that we might have. How do I get started? Should I get started, I guess, is a big point. Let's just run through that real quick. So first of all, you can't throw your people away. You need, AI is not going to make everyone redundant tomorrow. You still need good people. Even if eventually it changes the roles of what some of your people do, it's probably not going to replace them entirely. And you're always going to need good people to sort of design and maintain the AI system, as well as to interact with the AI system on a day-to-day basis. Like I said, AI tends to be quite probabilistic. So it makes a guess. It says, oh, I'm 80% confident or 60% confident or whatever the confidence rating is in that. And you need a human to sort of go, well, A, is that right? Probably. But B, based on that confidence rating, what should I do? What is the correct action to take here? So there's a lot of space in general for AI to augment the way that people work, and that's really, really important. The other thing is good data, because an AI system is only as good as the data that it's trained on. Now, for a lot of those common challenges that I outlined earlier, there's actually a number of what you call pre-trained models. So a company like Google may have a database of millions and millions of images and has trained an AI that's really, really, really good at recognizing objects in general, right? So you can start from there. You don't have to go and gather those millions of images. You can start from there, get the benefits of all of that, and deliver something quite effective reasonably quickly. But if you're going to solve some of those unique challenges that I talked about, you're going to need to have the data there, and it's going to need to be in a good shape, or you're going to need to invest the time in cleaning it up. And the volume of data is also important, depending on what technique and what you're looking for. And obviously this is on a case-by-case basis, but depending what technique and what problem you're solving, you may need a small amount of data, tens of thousands, you may need hundreds of thousands, you could need millions, right? And obviously millions of rows of data is probably not going to be practical for most organizations. But if you have in the tens of thousands or hundreds of thousands, you probably can get a good result with some techniques. But it's very, very specific, and again, you've got to map that data out and make sure that's available and accessible to the machine learning platform. Okay, so once you've sort of realized that you've got your people and you've got your data, you need to look at the challenges to solve. And there, of course, with any organization, there's lots of challenges. There's lots of things that you could solve. But here's sort of a recommendation of how I'd suggest looking at it. So similar to solving any problem, you first start with your overall challenges and priorities. I would probably then go looking for problems that can be automated. Where there's a lot of manual work going on, you'd think, gee, if we could automate this task, we'd save a bunch of time. That tends to be low-hanging fruit, because as I explained earlier, again, it's a common challenge. Most organizations have it. There should be a tool out there that can get you 90% of the way pretty quickly, hopefully. Then you might identify areas where you have data but don't have the insight. So like that New York blood bank example, we've got the data, we know who comes to our clinic, but we just don't know what really drives them to come back or make them want to give more. That's a unique challenge that if you spent the time on it, you probably could solve it with some machine learning. And then point 4, identify areas where you could offer more of an interactive experience. So like that charity water example I gave you, if there's a particular appeal or a particular campaign where you think if I could do something really a lot more interactive and a lot more personal, that would really, really drive the success of this campaign. Chatbots, machine learning might be able to help there. And then, of course, once you've got all your problems worked out, you want to rank them according to problem scope. Understanding of the problem, how well do I understand this problem and its drivers? The drivers maybe less so, but you've got to make sure you have a pretty clear understanding of the problem. Do I have the data volume and quality? So do I have the right amount of data? You probably can't fudge that, can't really get away with that. Do I have the right quality? You probably can fix that, but how much time am I going to need to spend fixing that? And then what human resources are available? Obviously, you're going to need AI specialists, and they're not easy to come by, but you'll need a bit of that. So a bit of AI expertise, probably some IT expertise in there as well. And then also the sort of people who are using the system or interacting with the system. Do I have some time or capability for these people to be involved as well? So in terms of the structure of an AI project, once you've sort of worked out that tapestry of what the challenges are, you go, all right, I'm going to pick this problem to start with. And that's definitely the easiest place to start. Don't go and pick the biggest, hardest problem and try and solve it tomorrow. It's probably not going to work. Pick something that's of, I guess, relative importance, but relatively low complexity as well. Define the problem and the hypothesis. So we think the problem is this. We think these are the key drivers, and this is what we think we're going to be able to solve it with. Gather and clean the data, so obviously identify all the different data sources, how you're going to connect them, clean them up if they need cleaning. You then train a proof of concept model from test data. So obviously, like I said, there's a lot of different techniques out there. The AI person will have to identify which tool to use, or if it's more of those unique challenges, which sort of set of algorithms and techniques to use. And we'll develop some kind of POC off that. Compare the POC model to existing solutions. So in some cases, there won't be existing solutions. In some cases, there will. Basically, to check how effective your POC is in real life. Refine that POC and then implement as a minimum viable product. So basically taking all that work that you've done to test it and develop it there and turn it into a working solution, and then continually monitor and retrain as required in production, right? So sometimes models, I guess, are reasonably generic or at a point where they can be reused, but most models probably need to be adjusted or improved over time. People change, underlying data changes, trends change. So there's an ongoing, like any project, there's an ongoing sort of maintenance aspect to it as well. And I guess something that's really, really important with AI projects is they're not like, I guess, well, all projects have probabilistic outcomes, but AI projects more so. Like I said, they're not, you do step 1, step 2, step 3, and then you get to step 4. Obviously, if you do step 3, which is train the POC model, and it's not working as well as you'd like it to, you might have to spend more time there. You may have to change tack. You may have to do any I guess, number of things to try and get it back on track. Because ultimately, an AI model produces an outcome which is a prediction at a certain level of accuracy. It's pretty much never 100%. It can be very, very close to that, but it won't ever be 100%. And that's something that I suppose you as a stakeholder and your wider stakeholder group have to understand. AI is not perfect. It gives you, I guess, superpowers, but they have downsides, and they're not 100% all the time. So that's really, really important to realize and to, I guess, explain early to the wider stakeholder group as well with an AI project. Last point, technology tools. So there are heaps of tools out there. On the right, that's the big data and AI landscape of 2018. There are lots and lots of vendors, again, like most software these days, lots of specific vendors with specific techniques and tools for very specific cases. If you look on the left, I've got the sort of the overview, and that's probably the easiest place to start. Google, all the big players, Google Cloud Platform, Microsoft Azure, Amazon Web Services, all have pretty well built out machine learning suites that are quite easy to access and get started with. Google in particular has a lot of online examples, like the one I showed at the start. So lots of examples there. IBM Watson is also another one, probably a little bit more expensive, but has a different set of functionality. And again, I think it's about, depending on your situation, you're probably already using some of these technology providers anyway. So if you're already using some of them, why not check out some of the machine learning capability that you need for your particular organization or project. So to wrap up, we've covered quite a bit, and I haven't kept time, but hopefully that's been helpful to everyone. To wrap up, AI is not a silver bullet. Again, we don't have the Terminators here today, but it is good for solving narrow problems at scale, whatever they might be. Point 2, AI is happening, just not overnight. So I don't advise you to run out tomorrow and tell everyone, oh, we've got to get this AI thing going like anyone's business. I don't think it's going to be AI replaces everything overnight, but what it is going to be is you're going to see more and more of it work its way into tools. You're going to see more and more organizations, both for-profit, not-for-profit, some, but definitely for-profit, adopting AI into their practices, and that will give them an edge. So you do need to be thinking about this and at least running some trial projects or some sort of learning around this to get ready for it. You still need a good process, and we covered like some of the project management and identifying opportunities already, good people and good data to make it work. And you still need people to work with the AI. Ultimately, you need to be able to tell the AI the problem to solve and to supervise its learning. And a lot of that's, again, on people. It's not in the tools. So if you do that really well, you have the right problem with the right people, the right data, and you follow a good process, you can solve a lot of problems. You just need to make sure you have all those things there. That's it for today. So thank you. Are there any questions? I haven't seen that. So,
Thanks, James. There haven't been any questions that have come through. I think it's a lot of information to take in. Um, so we'll give everybody some time to think it through. And I'll send out the slides and recording to everybody so that they have your contact details and can contact you with any questions if they do have any that come up later. So before I wrap up, is there anything that you wanted to add?
no, I mean, I think I covered it there. And look, thanks everyone for listening. I think, like I said, it's not going to happen overnight, but it is happening, and it's something that you need to be thinking about and starting, but don't panic either.
Most definitely. Thank you so much for presenting today, James, and thank you everyone else for joining us. I hope you've all learnt a lot from this presentation. If you do have any questions that do come to your mind later or any feedback about the webinar, please send that through to events@connectingup.org and we can answer those questions offline. You can also contact James directly via the information on your screen. Don't forget that the recording will be available on the website very shortly and a link will be sent to you, so keep an eye out on your inbox. Again, thank you for being with us. Enjoy the rest of your day and we look forward to seeing you all next time. Thanks, James. Thanks, everyone.
Well, thanks everyone. See you later.